going to do a standard Bernoulli's equation problem. Water coming down a pipe and coming out the other side. It has an initial velocity of 5 meters per second. It has a pressure of 2 atmospheres. Change in height. Let's make it 10 meters. Now, this pipe, let's just make it circular, has a radius of 5 centimeters and radius down here of 8 centimeters. Again, circular. Question, I want to know velocity at the bottom, and I want to know the pressure at the bottom. So for something like this, you need 2 equations. Equation of continuity. Don't care about spelling. And then this is P1. No, not that. This is why we have erasers, kids. Equation of continuity, A1, V1, A2, V2. Now, we've got everything that we need except for V2. A1, V1 over A2 is equal to V2. The areas are circular, so you got to go pi R1 squared V1 over pi R2 squared. Pi's cancel. Now, normally I would change to meters, but these are both in centimeters. The units cancel. It's unnecessary. R1, 5 squared. V1, 5. R2, 8. So 5 cubed divided by 8. So 15 point. Really? Hold on. Not that big. Ah, what do we see here? Forgot the square. There we go. Divided by 8. That number was way too big. There you go. 1.953 meters per second. Now, I'm not a big believer in sig figs. I just add a few more in the middle. Normally what I would do is I would just use this expression and substitute in into this Bernoulli's equation. Bernoulli's equation is my least favorite equation. Oh, by the way, water's going through this. Density of water is 1,000 kilograms per cubic meter. 1/2 rho V1 squared P2 plus rho GH2. I don't like it because it's very long. 1/2 rho V2 squared. And so now I'm looking for P2. One of the things that you need to do is you need to pick kind of like a base level for height. Since the difference is 10, that's really the important thing. But H2 is 0 and 10 is H1. So that goes away. And I'm left with P1 plus rho GH1 plus 1/2 rho V1 squared minus 1/2 rho V2 squared is equal to P2. The big question is, what units do I want the answer to be in? Because it changes how things go. 1, 2, 3 atmospheres, 4, 5, 6 newtons per meter squared. All right, answer, we need it in atmospheres. Now, P1 was already given in atmospheres. However, rho GH, this and this, when you multiply out the units, density is in kilograms per meters cubed. Velocity is in meters per second, but you square it. And what I'm going to do now, this is just some unit play to see the units. I'm only going to cancel one of these out. And then I'm going to bring this over. So 1 over meters squared, kilograms meters per second. Kilogram meter per second is a newton, or newton per meter squared. So since we need this in atmospheres, I'm going to take these three terms and divide it by a conversion. 1 atmosphere is equal to 1.013 times 10 to the 5th newtons per meter squared. This gives you 1 plus 1.013 times 10 to the 5th, 1,000 times 10 times 10 plus 1/2 1,000 V1 squared 5 squared minus 1/2 1,000 V2 squared 1.953 squared. And those three terms are all divided by 1.013 times 10 to the 5th. And that should give you I really like doing these dynamic content problems. I don't know where they're going. All right. And I get 2.092 atmospheres. And in my class, it'd be fine, 2.09 atmospheres. And so that is a Bernoulli's equation problem with the use of equation of continuity. Equation of continuity, Bernoulli's equation, and that is it. Thank you.